This is a question from discrete mathematics. Suppose A is a finite set with n elements. The number of elements and the rank of the largest equivalence relation on a set A are. So, what is an equivalence relation? A relation R is said to be an equivalence relation if it is reflexive, symmetric, and transitive. So, what is reflexive? A relation R on a set A is said to be reflexive if for all x belongs to A, x is related to x. This is reflexive. Second property is symmetric. A relation R on a set A is said to be symmetric if for any x comma y, x is related to y, then y is related to x. This is said to be the symmetric property. Now third one is transitive. Transitive. A relation R on a set A is said to be transitive if x is related to y and y is related to z, then x is related to z. This is said to be the transitive property. So now let's see the largest number of elements on a set A with n elements that is possible, which is equivalence. So if we have n elements, then maximum we can have n square elements in the largest equivalence relation. So this is the answer for the largest equivalence relation with n elements. The answer is n square. Now let's see the rank of the largest equivalence relation. To calculate the rank, suppose n is equal to 3. If n is equal to 3, then it contains 3 elements A1, A2 and A3. Now let's draw the equivalence relation. If the largest possible equivalence relation contains every element is related to every other element. So the answer would be n square here. If n is equal to 3, it will be 9. So the relation A can be denoted as 1, 1, 1, 1, 1, 1, 1, 1, 1. The elements are A1, A2, A3. Here also A1, A2, A3. This means that since it's follow reflexive, all the diagonal elements are related. So A1 is related to A1, it means this. A2 is related to A2, this means this. And A3 is related to A3. So reflexive property satisfied. Similarly, symmetric property. A1 is related to A2 and A2 is related to A1. Similarly, all these properties reflexive, symmetric and transitive is being held by this relation. Now let's calculate the rank. We can rewrite the equation as R2 implies R2 minus R1 and R3 implies R3 minus R1. So the relation can be rewritten as follows: 1, 1, 1, 0, 0, 0, 0, 0, 0. So this means that rank of this relation matrix is equal to 1. Now what is rank? Rank of an equivalence matrix is the number of equivalence classes induced. Here only one equivalence class is there. So as a result, rank is equal to 1 and the number of elements in the largest possible equivalence relation is n square. So the correct answer is option C, n square, 1. This is a question from discrete mathematics. Consider the set of integers I. Let D denotes divides with an integer quotient. Example 4D8 but 4D7 is not possible. So it means that 4 can divide 8 but 4 cannot divide 7 with an integer quotient. Then D is, and 4 options are given. So first of all, let's see the properties. Reflexivity. This is not possible because for all x belongs to I, we can say that R of x comma x is reflexive. But if x is equal to 0, that is R of 0 comma 0 is not possible because 0 cannot divide 0. So the property of reflexive is not satisfied. So option A cannot be the correct answer. Even option C cannot be the right answer. So let's see the other properties. The second property is symmetric. Symmetric. For symmetric, for all x belongs to I, r of x comma y and r of y comma x is symmetric. And clearly the above relation cannot be symmetric because consider the example. S is equal to 1 comma 2. So it means that 1 comma 2 is in the relation as well as 2 comma 1 should be in the relation, but 1 comma 2 can be in the relation but 2 comma 1 cannot be in the relation. So symmetric property is also not satisfied. So let's see the next option, that is anti-symmetric. In anti-symmetric we can say that for all x belongs to I, r of x comma y and r of y comma x, it means that x is equal to y is said to be antisymmetric. But we can say that the violation is easily occurring here also because r of minus 2 comma 2 and r of 2 comma minus 2, this is not antisymmetric. Not antisymmetric. Let's see the transitivity property. Transitivity. For transitivity, we can say that for all x belongs to I, r of x comma y and r of y comma z, then r of x comma z should occur. This is true for the above relation. For example, 2 comma 4 as 2 divides 4 and 4 comma 8 as 4 divides 8. Then 2 comma 8 is possible because 2 divides 8. So the given relation is not reflexive, not antisymmetric, and transitive. So option B, not reflexive, not antisymmetric, and transitive is the correct answer here. This is a question from probability. A bag contains 19 red balls and 19 black balls. Two balls are removed at a time repeatedly and discarded if they are of the same color. But if they are different, black ball is discarded and red ball is returned to the bag. The probability that this process will terminate with one red ball is, and four options are given. Let's consider the different cases. When we pick up two red balls, let's denote it as R and R. Both are removed. When we pick up both black balls, both are removed. Now when we pick up red and black, what happens is black is removed and red is kept. Similarly, black and red, the same situation happens. So what happens in the second last trial? The final contents of the bag would either be red and black, or it would be red, red and red. Why does this happen? Because since we are anyhow discarding and removing the black balls, we'll be having one black balls at last. Then in that case, we'll be having one more red. If all the black balls are removed, then ultimately we'll be having only three red balls. In either of the two cases, let's consider these scenarios. So for red and black, what happens is red and black would be removed and red will be kept. So this process would terminate with one red ball. Now let's consider the other case, RRR, where all the three balls are red. In that case, two red balls would be taken and they will be removed, and finally we will be having one more red ball. So in this case also we'll be having one red ball. So the probability that this process will terminate with one red ball is 1, because in both the cases we are terminating with a red ball. So the correct answer to this question is option A, 1. This is a question from engineering mathematics. If x equal to -1 and x equal to 2 are extreme points of f of x equal to alpha log x plus beta x square plus x, then value of alpha and beta are. To find out the extreme points, we find out the first order derivative and equate it to 0. The first order derivative of this particular equation is alpha by x plus 2 beta x plus 1. And at x equal to -1, we have minus alpha minus 2 beta plus 1 equal to 0. And at x equal to 2, we have alpha by 2 plus 4 beta plus 1 equal to 0. Now solving these two equations, that is 1 and 2, we will get alpha is equal to 2 and beta is equal to -1 by 2. And the correct answer is option B, alpha equal to 2 and beta equal to -1 by 2. This is the correct answer. This is a question from engineering mathematics. Let f of x be log modulus x and g of x be sin x. If A is the range of f of g of x and B is the range of g of f of x, then A intersection B is, and four values are given. Let's write f of g of x first. That is, f of x is log of modulus x, that is mod g of x, which is equal to log of sin x. Now, the value of sin x ranges from -1 to 1. This is given as the input to log of this value. So, the domain we know here is 0 to 1 for sin x, as we are considering only positive value due to modulus. So, this will give a range of -infinity to 0. This is A. Now, let's consider the second expression, g of f of x. This is equal to sine of f of x, which is equal to sine of log modulus x. Now, log modulus x will give a value between -infinity to +infinity. This is given as input to the sine function, which would give a range in the between -1 to 1. So now we have both the values of A and B. They are A is in the range of -infinity to 0 and B is in the range of -1, 1. So A intersection B is equal to -1, 0. And let's see the options. Going by the options, option A is the correct answer here. This is a question from propositional logic. The proposition P implies Q and Q implies P is, and four options are given. Let's draw a truth table for this given proposition. We have P, we have Q, P implies Q, Q implies P. Let's denote it as 1 and 2. Then we have 1 and 2. This is this expression. Let's write the values. True, 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 false, false, true, and false, false. So for P implies Q, it is only false in which case when P is true and Q is false. For rest of the cases, it is true. So this is true, this is false, this is true, and this is true. Similarly, for Q implies P, it is false only when Q is true and P is false. So first case it is true, second case it is true, third case it is false, fourth case it is true. Now we are performing AND operation. For true and true, it is true. True and false, it is false. True and false, it is false. True and true, it is true. Since the final result is not completely tautology or it is not completely contradiction, that is, it is not tautology or contradiction. We can say a proposition is tautology if it returns true for all true table values. We can say it is contradiction if it returns false for all true table values. Here it is not returning tautology or contradiction. So a proposition which is neither tautology nor contradiction is a contingency. So based on the options, option C is the correct answer. This is a question from discrete mathematics. If T of x denotes that x is a trigonometric function, P of x denotes that x is a periodic function, and C of x denotes that x is continuous function, then the statement, it is not the case that some trigonometric functions are not periodic, can be logically represented as, and four options are given. Let's try to solve it. So if P is a predicate, then negation P means that it is not the case P, or simply not P. This is what P and negation P means. Now let P denote some trigonometric functions are not periodic. Some trigonometric functions are not periodic. This means that there exists a function which is trigonometric and not periodic. It can be written as there exists some x such that T of x, that is, there is a function which is trigonometric and not periodic, not P of x. We can write it like this. Now negation P, it means that it is not the case that some trigonometric functions are not periodic. So this can be written as negation P means negation of the x T of x and negation P of x. So this can be rewritten as there exists x such that T of x and negation P of x. So based on the options, option A is the correct answer here. This is a question from discrete mathematics. The number of elements in the power set of 1 2, 2 1 1, 2 1 1 2 is, and four options are given. So consider this. Consider this. That is set 1 and set 1 comma 1. These are both same set. This is because order and repetition of the elements in the set won't make it a new set. That is, order and repetition of elements in a set won't make it a new set. This is an important point to remember. Now we have here 1 comma 2, 2 comma 1 comma 1, 2 comma 1 comma 1 comma 2. These are all same. So the total number of elements in A, this is A, is only 1. So the number of elements in power set is 2 to the power of n, where n represents the number of elements. Here n is equal to 1. So we have 2 to the power 1, which is equal to 2. So the correct answer is option D, 2. This is a question from engineering mathematics. The function f in the domain 0 to 3 and defined till the range 1 to 29 for the function f of x, that is 2x cube minus 15x square plus 36x plus 1 is, and 4 options are given. Let's write f of x is equal to 2x cube minus 15x square plus 36x plus 1. F dash of x can be written as 6x square minus 30x plus 36. Taking 6 as common, we can write it as 6 into x square minus 5x plus 6. This can be again rewritten as 6 into x minus 2 into x minus 3. These are the factors. Now f of x has minima and maxima at x equal to 3 and 2 respectively. Since f of x is non-monotonic in 0 to 3, we can say that f of x is not 1 1, and f of x is increasing in the range of x from 0 to 2 and decreasing in 2 to 3, as f of 0 is equal to 1 and f of 2 is equal to 29 and f of 3 is equal to 28. Since f of x is continuous, so range of f of x is minimum and maximum between 0 to 3. We can say that. So minimum is at value x equal to 1. Minimum value is 1 and x will be equal to 0, and maximum value is 29 at x is equal to 2. Therefore, range of f of x is 1 to 29. So f of x is onto. So we can say that f of x is surjective but not injective. This is the important point. And based on the options, option B is the correct answer. This is a question from engineering mathematics. We are given two vectors. Vector A is equal to 2i plus lambda j plus k, and B equal to I minus 2j plus 3k, and they are perpendicular to each other. We are asked to find out the value of lambda. Since the two vectors are perpendicular to each other, the dot product is 0. So let's calculate the value of lambda. Since they are perpendicular to each other and the dot product we can find out, we can write it as 2i plus lambda j plus k dot I minus 2j plus 3k is equal to 0. We can write it like this. Now let's calculate the value of lambda. We can write it as, we multiply it like this, 2 into I lambda j minus 2j k plus 3k. So multiplying, we can write it as 2 minus 2 lambda plus 3 is equal to 0. 5 minus 2 lambda is equal to 0. 5 is equal to 2 lambda. We can write lambda is equal to 5 by 2. Implies lambda is equal to 5 by 2. So the correct answer is option D, 5 by 2. This is a question from database. Consider the schema sailors where the attributes are SID, SNAME, rating and age with the following data here. We are given a query, select S dot rating, average of S dot salary as average age from sailors S, where S dot age is greater than 18, group by S dot rating, having 1 less than select count star from sailors S2, where S dot rating is equal to S2 dot rating, and the number of rows returned is. So first of all, in this query, the where condition is executed first. So only those rows which are having age greater than or equal to 18 will get selected. So based on that, this row gets selected, this row would get selected, this row, this row. Since it is less than 18, it won't get selected. This would get selected, it won't get selected, this would get selected, this would get selected, and this would get selected. So the total number of rows that would get selected, and for the sake of simplicity, I'm just writing the SID with rating. So we will be having 22 7, that is SID and rating. Then we have 29 and rating is 1. We have 31, rating is 8. 32, rating is 8. Then we have 64, the rating is 7. Then we have 74, rating is 9. 85, rating is 3. 84, rating is 3. 96, rating is 3. 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 rows will be written based on the where condition. Now we are grouping it by S dot rating. So since we are grouping it, how many groups will be there? So let's see the groups based on rating. So let's see 7. For 7, how many groups we have? 1. For rating 7, we have 22,7 and 64,7. This is one group. Next group, we'll add 1. For 1, we have 29,1. Next group, we have 8. 8 we have how many times? 2 times. 31 and 32 are having 8. Next we'll have 9. For 74 only 1 9. And last we have 85, 84, 96. All these are having rating 3, 3 and 3. Now this condition, having 1 less than select count star from sailors S2, where S dot rating is equal to S2 dot rating. What does this query does? This query returns only those rows whose count is having greater than 1. So here what happens is this group would be returned since its count is greater than 1. This group will not be returned. This group would be returned. This group will not be returned, and this group will be returned. So in total 3 rows, this 1, this 2 and this 3. 3 rows would be returned. So the correct answer is option D, 3. This is a question from databases. Consider a table that describes the customers, and the table has 4 attributes. One is customer ID, name, gender and rating. The rating value is an integer in the range 1 to 5 and has only 2 values, male and female, are recorded for gender. Consider the query, how many male customers have a rating of 5? The best indexing mechanism appropriate for the query is, and four options are given: linear hashing, extendable hashing, B plus tree, and bitmapped hashing. Since the rating value is an integer in the range of 1 to 5 and only two values, that is male and female, we can assume male as 0 and female as 1, are recorded for gender. We can see that both the values of rating as well as the value of gender are fixed. So bitmapped indexing is best suitable for this. So option D, bitmapped hashing, is the correct answer. This is a question from Java. Type 4 JDBC driver is a driver and four options are given. First of all, let's understand the concept of type 4 JDBC driver. It is a driver which works directly by connecting to the database server through socket connections and convert JDBC calls to vendor specific database protocols. These drivers do not require any intermediate layer. Let's see the options. Option A, written in C++. No, this is wrong. Option B, it requires an intermediate layer. Actually, it does not require any intermediate layer. So option B is wrong. Which communicates through Java sockets. Yes, it actually communicates through Java sockets. So this can be a correct answer. D, which translates JDBC function calls into API, not native to DBMS. Actually, it converts JDBC calls to vendor specific database protocols. So option D is also not correct. So the correct answer is option C. This is a question from algorithms. We are given a recurrence relation T of n is equal to 2T of n minus 1 if n greater than 0 or it is equal to 1 otherwise. Then T of n is in order of what? And four options are given. Let's solve this recurrence relation. It is given that T of n is equal to 2 into T of n minus 1 if n is greater than 0. So solving further, we can write that T of n minus 1 is equal to 2 into 2T of n minus 2, which is equal to 2 square T of n minus 2. Again, further solving, we can write it as T of n minus 2 is equal to 2 into T of n minus 3. Now again we can write T of n is equal to 2 square into this T of n minus 2 can be substituted using this 2T of n minus 3, that is 2T of n minus 3, which is equal to 2 cube T of n minus 3. Iteratively solving till k, we can write as T of n is equal to 2 to the power k into T of n minus k. Now n minus k equal to 0, we can assume that because this will continue till n minus k becomes 0. At that point T of n will be 1. So if n minus k equal to 0, then n is equal to k. So we can write it as T of 0 is also equal to 1. Solving, we can write as T of n is equal to 2 to the power k into 1. So T of n is order of 2 to the power n. Option B is the correct answer here. This is a question from programming. Consider the program and we are given a function which is accepting an integer n, and there are two other integers I, j, and one more integer count which is initialized to 0. Now two loops are given. One loop is for I equal to n by 2, I less than or equal to n, I plus plus. Another loop is for j equal to 1, j less than or equal to n, j equal to j into 2, and count plus plus. What is the complexity of the program? Both the loops are running independent of each other because there is no dependent variable which is controlling the flow. So independent loops. This is the important point. Now this loop runs for n by 2 time, and this loop, if you can see, it runs till log n time. So we can say it as it runs till n by 2 into log n. In terms of big O, it is almost order of n log n. So the correct option is option D, order of n log n. This is a question from algorithms. Match the following and choose the correct answer for the order A, B, C, D. We are given four algorithms here. and 4 design techniques. Let's see how we can match the options. Option A, Strassen matrix multiplication. It uses divide and conquer technique to reduce the complexity of matrix multiplication. So A will be mapping to R. Now itself we can see these two options are eliminated. Let's focus on these two options. Second one is insertion sort. Insertion sort actually uses decrease and conquer approach as it is loop invariant, and in each step one element is being transferred into the sorted half of the array. So insertion sort uses decrease and conquer. So B is P. From here itself, going by the options, we can say option B is the right answer. But let's see the rest of the options. Gaussian elimination actually uses transform and conquer approach to solve the equation. So this is C will be S, and Floyd-Warshall algorithm, it uses dynamic programming to solve the all pair shortest path algorithm. So going by the options, option B is the correct answer. This is a question from theory of computation. For sigma equal to a comma b, the regular expression r equal to aa whole star followed by bb whole star followed by b denotes. 4 options are given. Let's see each option one by one. Option A, set of strings with 2 a's and 2 b's. This is false. A counter example would be aa, bb, b. This is not a set of string with 2 a's and 2 b's. We have actually 3 b's here. Let's see option B. Set of strings with 2 A's followed by 2 B's and 1 single B. Here this option is also not correct. We can generate a string AA, AA, BB and B. This is a set of string with 4 A's, 2 B's followed by B. This is also not correct. Set of strings with 2 A's followed by B's, which is a multiple of 3. This is also not correct. We can write an example as AAB. This is set of string with 2 A's followed by B, which is only 1. It is not a multiple of 3. So this is also not correct. Let's see option D. Set of string with even number of A's followed by odd number of B's. Yes, this is the correct option because here we can generate even number of A's followed by odd number of B's, because in the end there is always one odd number of B. Here it is generating even number of B's. So ultimately B's would be odd and A's would be even. So option D is the correct answer here. This is a question from theory of computation. Consider the following grammar with productions S derives ASB, SS or epsilon. This grammar is, and 4 options are given. So according to Chomsky hierarchy, context-free grammars are those grammars with productions which follow the production rule such that it is of the form A derives B, where A is a non-terminal and B is a set of non-terminals and terminals. So the given grammar follows this hierarchy. So it is a context-free grammar. So option A and B are not valid here. Let's see other 2 options. Here one more option is given. It is linear or not linear. According to linear grammar, it is a context-free grammar that has at most one non-terminal in the right-hand side of each of its productions. So the given grammar cannot be a non-linear because of the production S derives SS. There can be at most only one non-terminal. Here there is 2 non-terminals. So the given grammar is not linear. So option C is the correct answer. It is context-free as well as not linear. This is a question from theory of computation. Identify the language generated by the following grammar. We are given a grammar with productions S derives AB, A derives AA, B or epsilon, B derives BB or B. And let's see the options. So from the productions, one thing we can understand is that A and B are the non-terminals which can generate the terminals. So A can always generate equal number of A's or B's, or it can generate an epsilon. Now seeing B, B can always generate at least one B. So in minimum, this grammar can produce at least one B. That is the first criteria. So the number of A's and b's will be in the form that a will always be less than b, because this will generate equal number of a's and b's, or this can generate epsilon. So a can generate equal number of a's and b's or epsilon, but b will always generate a minimum 1b. So the number of a's will be less than number of b's always. Also in minimum, the minimum length string that can be generated is b. So going by the options, we can say that this generates a power m, b power n, and based on the criteria we can always say that number of a's is always less than number of b's. So n will always be greater than m. So either C or D can be the correct answer here. Now the next condition is m is greater than 0 or m is greater than or equal to 0. Here m can be equal to 0 also, because this string can generate b only. So to generate b, it should be a power 0, b power 1. So it can be 0 or it can be greater than or equal to 0. So m can be greater than or equal to 0. So based on the conditions, option D is the correct answer. A power m, b power n, where n greater than m and m greater than or equal to c. This is the language generated by the above grammar. This is a question from theory of computation. Let L1 be a regular language. So L1 is regular. L2 be a deterministic context free. DCFL. L3 is recursively enumerable language but not recursive. Which of the following statements is false? Let's see first option. L1 intersection L2. As L1 is regular and L2 is DCFL, regular languages are closed under intersection. So as a result, L1 intersection L2 is context free. This option is true. L3 intersection L1 is recursive. L3 is REL but not REC, and L1 is regular. So this option is false, because L3 is recursively enumerable but not recursive. So intersection with L1 must be recursively enumerable but may or may not be recursive. So this option is a potential option for the correct answer. L1 union L2 is context free. As regular languages are closed under union also, L1 union L2 is context free. This is also true. Option D. L1 intersection L2 intersection L3 is recursively enumerable. So L1 intersection L2 is DCFL, because regular languages are closed under intersection. And DCFL intersection L3 is recursively enumerable, because DCFL is in turn recursively enumerable, and recursive enumerable intersection recursive enumerable is also recursively enumerable. So this is also correct. So among the options, option B is the statement which is false. So option B is the correct answer here. This is a question from theory of computation. Let L be a language which is of the form a to the power p, where p is a prime number. Then which of the following is true? Option A, it is not accepted by a Turing machine. False. It can be accepted by a Turing machine. Option B, it is regular but not context free. A to the power p, where p is a prime, is not a regular language as well as it is not context free. So option B and C are false. Let's see option D. It is neither regular nor context free but accepted by a Turing machine. Yes, this is true, because a power p is not regular or context free. It is accepted by Turing machine. So option D is the correct answer here. This is a question from theory of computation. Which of the following are context free? Let's see each options. Option A power n, b power n, a power m, b power m, where n comma m greater than or equal to 0. This is context free, because for calculating this we can push a's into the stack, and for each b we can pop it. Then for the next a's and b's, similarly we can push it into the stack, the a's, and upon seeing b's we pop it. So this, and if the stack is empty, this is accepted. So this is a context free language. Option B, it is not context free. That is a power m, b power n, a power m, b power n, m comma n greater than or equal to 0. This is not context free because using a single stack we cannot properly compare M and N. So this is not a context free and this is a context sensitive language which requires two stack for comparison. Option C, A power M, B power N, M not equal to 2N, M comma N greater than or equal to 0. This is also context free. We can push A's into the stack and for each B we can pop the stack twice. So if the stack is empty then the string is not accepted. So option C is also context free. So based on the options, option A and C is correct. So the correct option is option B. A and C is the correct answer. This is a question from theory of computation. Let S be a NP complete problem and Q and R be other two problems not known to be in NP. Q is polynomial time reducible to S and S is polynomial time reducible to R. Which of the following statements is true? It's given that S is NP complete. That is NP and NP hard. We know that if NP hard problem is polynomial time reducible, then the problem is also NP hard, which means that every NP can be reduced to this problem in polynomial time. Therefore, R is NP hard. Q is reduced to S in polynomial time. If Q is reduced to S in polynomial time, Q could be in NP because NP problems could be reduced to S. Since Q could be NP, therefore Q could be P as P is a subset of NP. Also Q could be NPC because every NPC problem can be polynomial time reduced to another NPC problem. So we cannot conclude anything about Q here. Q cannot be concluded. So the correct option is option B. R is NP hard. This is a question from data structures. The number of structurally different possible binary trees with 4 nodes are. This can be found out using the Catalan number. And the formula to find the number of different structurally possible binary trees are 2n the whole factorial divided by n plus 1 the whole factorial into n factorial. And here n is equal to 4. So we have 8 factorial divided by 5 factorial into 4 factorial. We can rewrite it as 5 factorial into 6 into 7 into 8 divided by 5 factorial into 1 into 2 into 3 into 4. Cutting 5 factorial and 5 factorial, we can cut 8 and 3 with 2. So we have 14. So the correct answer is option A, 14. This is a question from network security. Using public key cryptography, X adds a digital signature sigma to the message M, encrypts M comma sigma and sends it to Y, where it is decrypted. Which one of the following sequence of keys is used for operation? It is indicated that X adds digital signature to the message and then encrypts it and send. So these are the following sequence of operation that has to be done. For the first part of adding digital signature and encrypting, the following steps are involved. X in first step adds the private key of X, private key, to encrypt the message as a digital signature. Now the message will be M comma sigma and this is again encrypted in step 2 using Y's public key. Now as this is sent, upon receiving the message, Y will decrypt it using initially Y's private key. Now we will have the digital signature and the message incorporated in it. So to decrypt it again, we use X's public key. This is the step involved. Initially, using private key of X, it is encrypted. Then using the public key of Y, this is encrypted. Then using Y's private key, it is decrypted, and using X's public key, it is decrypted. So let's see the option. Encryption using X's private key followed by Y's public key. Decryption using Y's private key followed by X's public key. Option C is the correct answer here. This is a question from network security. Which of the following are used to generate a message digest by the network security protocols? Let's see each option. Option A, SHA-256. Yes, SHA-256 is a cryptographic hash function that can produce 256-bit hash value. So SHA-256 produces 256-bit hash values. So this can be used to generate a message digest. Now AES and DES are both encryption algorithms. So they are not used to generate message digest. Let's see option S, that is MD5. Even MD5 is used as a cryptographic hash function that can produce 128-bit hash value. MD5 produces 128-bit hash value. AES and DES are encryption algorithms, whereas SHA-256 and MD5 are used to generate the message digest. So P and S are correct here. So option A, P and S only, is the correct answer here. This is a question from computer networks. In the IPv4 addressing format, the number of networks allowed under Class C addresses are. IPv4 is a 32-bit addressing format. Here, for Class C, the addressing is divided into two parts, 24 bits and 8 bits. This 24 bits is for network ID and 8 bits is for the host ID. But even in this 24 bits, initial 3 bits are reserved and they are 1, 1 and 0. So rest of the 21 bits are only used for assigning and the rest 8 bits are for the host. So the total number of networks that are allowed is 2 to the power 21 here. So option D, 2 to the power 21, is the correct answer. This is a question from computer networks. An internet service provider has the following chunk of CIDR based IP addresses available with it, and the address is 245.248.128.0/20. The ISP wants to give half of its chunk of addresses to organization a quarter of it to organization B, while retaining the remaining with itself. Which of the following is valid allocation of addresses to A and B? Since we have /20, it means that from 32 bits, 20 bits are already allocated. We have remaining 12 bits. So 2 to the power 12, we have 4096 addresses available with us. Since one half of this has to be given to organization A, so let's write 20 in binary. First 8 would be 8 ones would be continuous ones. Next 8 would be also continuous one. 20 means next 4 would be 1 1 1 1. So in order to assign half of 4096 to organization A, let us make the 12th bit as 1. So this means that next bit can be assigned as 1. So this is given to organization A. This means that now the address will be looking like this: 88 plus this bits. So we will be having /21 here. Also the address will be 245.248.128, and with this we will get 136.0/21. So this can be a potential candidate as answer. Then the 12th bit can be set to 0 also. So let's set 12th bit to 0 also. Then we have 0 0 0 0 as the remaining bits in the third octet. Now we have to assign only next quarter to organization B. So let's assign the 13th bit as 1 for this. So we'll be having 0 1 0 0. Now as a result of this, we will have 1 1 1 1 0 1 0 0. We have in total, this would mean 128.0/22. So as a result, option A is the correct answer here. Here we are performing OR operation with 128. 128 means 1 0 0 0 0 0 0. Here 4. Here one more 0 is needed. So once we perform the AND operation, we will get 128.0. So the correct answer here is option A. This is a question from computer networks. Assume source S and destination D are connected through an intermediate router R. How many times a packet has to visit the network layer and data link layer during transmission from S to D? One important point to remember here is that source S and destination D have only one network layer and one data link layer. Whereas for router R, there is two data link layer and one network layer. Two data link and one network layer. So in total, for source S, destination D and router R, the data link layer would be one here and two here. This is data link. And for network layer, it would be 1, 1 and 1. This is network layer. So as a result, this would be 4 and this would be 3. So going by the options, we can see network layer is 3 times and data link layer is 4 times. So option D is the correct answer here. Source S. This is a question from computer networks. Generally, TCP is reliable and UDP is not reliable. DNS, which has to be reliable, uses UDP because, and 4 options are given. We can say that the maximum size of UDP datagram is 512 bytes and it will fit within the UDP segments. So as a result, UDP is faster. So based on that, we can say that DNS requests are generally very small and fit well within UDP segments. So answer C is the correct. But there are one more point to note, that is DNS uses both TCP and UDP ports 53. For larger responses like zone file transfer, TCP on port 53 will be used and not UDP on port 53. So in general, since DNS requests are very small and fit well within UDP segments, they are used. This is a question from computer networks. Consider the set of activities related to email. A. Send an email from a mail client to a mail server. B. Download email headers from mailbox and retrieve mails from server to a cache. C. Checking email through a web browser. The application level protocol used for each of the activity in the same sequence is. So first of all, to send a mail from a mail client to a mail server, we use a simple mail transfer protocol. So this uses SMTP. Option B. Download email headers from mailbox and retrieve mails from the server to a cache. For this, we can use IMAP. IMAP is an application level protocol that stores emails on the mail server and allows the end user to view and customize the message if they are readily stored in the end user's device. So this uses IMAP. And to check email through a web browser, we can use HTTPS. So SMTP, IMAP and HTTPS. SMTP, IMAP and HTTPS, option C is the correct answer here. This is a question from computer networks. Station A uses 32-byte packets to transmit a message to station B using sliding window protocol. The round trip delay time between A and B is 40 milliseconds and the bottleneck bandwidth on the path A and B is 64 kilobits per second. What is the optimal window size that A should use? So here we are given that the round trip delay RTT between A and B is equal to 40 millisecond. That is 40 into 10 to the power of minus 3 seconds. And the frame size is given as 32 byte. So frame size, let's consider it in bits, which is equal to 32 into 8 bits. And the bandwidth is equal to 64 into 10 to the power of 3 bits second inverse, that is bits per second. These are the information that is given. So the transmission time is equal to frame size by bandwidth, which is equal to 32 into 8 by 64 into 10 to the power of 3. If we put it here, it will be milliseconds. So it is 64 and 32 will cut it, 8 and 4, 2 and 4 will cut, and the final answer is 4 milliseconds. That is the transmission time. Now let's consider the window size as n. N is the window size. Now utilization eta is equal to n by 1 plus 2a, where a is equal to propagation time divided by transmission time. Let's denote transmission time as Tt. So we have eta is equal to n by 1 plus 40 by 4. Solving, we will get n is equal to 11. So the closest answer to this is 10. So option B, 10 is the correct answer here. And for the maximum utilization, we consider eta as 1. So we'll get 1 equal to n by 1 plus 2a. Solving, we will get n is equal to 1 plus 2a. This would be the answer. So finally, n is equal to 11 and the closest matching option is 10. Option B. This is a question from computer organization. A two-way set associative cache memory unit with a capacity of 16 KB is built using block size of 8 words. The word length is 32 bits. The physical address space is 4 GB. The number of bits in the tag and set fields are. So let's calculate the total cache size. Total cache size here is 16 KB. That is 2 to the power of 14 bytes. Now word length equal to 32 bits. That is one word equal to 2 to the power of 2 bytes. Since the word length is given, we can assume the memory to be word addressable and not byte addressable. So here we have total number of words in the cache that can be calculated as 2 to the power of 14 by 2 to the power of 2, which is equal to 2 to the power of 12 words are there in the cache. Now one block is equal to 8 words. So block offset is log to the base 2 of 8, that is 3 bits is the block offset. Now cache size in terms of blocks is equal to cache size in blocks is equal to how many blocks we have as of now. 2 to the power of 12 blocks is there. 2 to the power of 12 words are there. 2 to the power of 12 by what is size of one block is 8 words. So 2 to the power of 3, that is equal to 2 to the power of 9 blocks are there in the cache. Now we have a two-way set associative cache. So we are dividing it again by 2. So we get 2 to the power of 8. So we have 2 to the power of 8 sets. So the set offset is 8 here. So going by the options, either B or C can be the correct answer. Now let's calculate the rest. It is given that the total physical address space is 4 GB, which is equal to 2 to the power of 32 bytes, and in words it is equal to 2 to the power of 32 by 2 to the power of 2, which is equal to 2 to the power of 30 words. So we can calculate the physical address out of 30 bits. So as of now, out of 30 bits, out of the 30 available bits, 3 bits have been given for the word offset, and we have given 8 bits for the set offset, set word. So now we have remaining 19 bits. This is the tag offset. So the correct option is 19,8, and the answer is option B. This is a question from computer organization. A CPU has a 32 KB direct mapped cache with 128 byte block size. Suppose A is a two-dimensional array of size 512 into 512 with elements that occupy 8 bytes each. Consider the code segment. For I equals 0, I less than 512, I plus plus. For j equal to 0, j less than 512, j plus plus. X equal to x plus a of ij. Assume the array is stored in the order a of 0, 0, 0, 1, 0, 2. The number of cache misses are. So the array is stored in row major form. Row major form. This is the important point that we can assume based on this. So let's see how to calculate the answer. So number of elements in one block of the cache is equal to, the cache block size is 128 and each element is 8 byte. So we have 16 elements in one block. So ideally block 0 has a of 0, 0 to a of 0, 15. Block 1 would have a of 0, 16 to a of 0, 31, and so on. Now assume I equal to 0, that is the initial iteration. A of 0, 0 will not be in the cache. So it is a compulsory miss. This is a compulsory miss. Now for the next 15 elements, there will be no miss because they are already fetched into the cache. So after every 16 elements, the miss will occur. So the total number of misses when I equal to 0 is, we have 512 iteration. 512 divided by 16, that is the size of elements in a block. So we have 32. So for I equal to 0 to I equal to 512, the number of misses can be calculated as number of iteration into number of misses in one iteration. Number of misses in one iteration. So we can calculate it as number of iteration is equal to 2 to the power of 9 into 2 to the power of 5. The iterations will be 2 to the power of 9, that is 512, and the number of misses we calculated it as 32, that is 2 to the power of 5. So we have 16384. So the correct answer is option A, 16384. This is a question from computer organization. A CPU has a 32-bit. This is a question from Digital Logic. A computer with 32-bit word uses 2's complement to represent numbers. The range of integers that can be represented by this computer is, and 4 options are given. First of all, let's understand the formula to find out the number of representations or the range of an n-bit number in 2's complement binary representation. Range of n-bit number in 2's complementation, that is equal to minus of 2 to the power n minus 1 to 2 to the power n minus 1 minus 1. This minus 1 is for the extra 0 representation. Here there is no negative value representation for 0, only there is one single representation. So substituting the value of n equal to 32, we get minus of 2 to the power 31 to 2 to the power 31 minus 1. And going by the options, option C is the correct answer here. This is a question from digital logic. Let m equal to a binary string is given and let n equal to another binary string is given. Be two 8-bit 2's complement number. Their product in 2's complement is. So let's write m in its decimal form. M is equal to 1111 followed by 1010. N is equal to 00001010. So let's calculate these values. Here we can write 8421. These are the place values: 16, 32, 64, 128. So the m value is, since these are all from here to here it's continuous one, this part can be directly ignored. So we can write it as minus 8. This would be the value minus 8 plus 2, which is equal to minus 6. And this, since this bit is 0, it will be a positive number. This bit is 1, that's why it is a negative number. So this would be 10. So m into n is ideally minus 6 into 10, which is equal to minus 60. So let's see each option one by one to see how they are represented. 1 1 0 0 0 1 0 0. The place values are 128, 64, 32, 16, 8, 4, 2, 1. So this is a negative number, so this can be an answer. So the final value will be minus 128 plus 64 plus 4. So we have 60 or minus 60. Yes, minus 60. So option A is the correct answer here. This is a question from computer organization. For a CPU having pipeline with a single ALU, consider the following. A. The J plus first instruction uses the result of the jth instruction as an operand. B. Conditional jump instruction. C. Jth and J plus first instruction require ALU at the same time. Which one of the above causes hazards? Let's see each of the options. First, A is given as J plus first uses result of jth instruction as operand. This is an example of a data hazard. A data hazard arises when an instruction depends on the result of the previous instruction in a way that it is exposed by the overlappings of instruction in the pipeline. So A is a data hazard. So this is a hazard. So let's write it here. A is data hazard. B. B is a conditional jump instruction. A conditional jump instruction always creates a control hazard because of the pipelining of branches and other instruction that can change the program counter. So conditional jump instruction also cause hazard, that is control hazard. Now see, J and J plus first instruction require ALU at the same time. This is actually a structural hazard because since there is only a single ALU, both J and J plus first instruction requires the ALU. As a result, a structural hazard arises. This arises because resource conflicts are occurring when the hardware cannot support all the possible combination of instruction in simultaneous overlap execution. So as a result, C is a structural hazard. And the question asked is which of the above causes hazards? Both A, B and C all causes hazards. So the correct option is option D. This is a question from computer organization. In designing a computer's cache system, the cache block size is an important parameter. Which one of the following statements is correct in this context? Smaller block size incurs lower cache miss penalty. Option A is correct. To service a miss, we have to introduce the block in the cache. Smaller block size means smaller service time. So option A can be a correct option. Let's see option B. Smaller block size implies better spatial locality. Spatial locality would be meaning the neighboring pages has to be introduced. So larger the block size, more would be the neighbors that we could take in. So this option B cannot be the correct answer. Option C. Smaller block size implies smaller cache tag. Actually, if the assume we are using a direct mapped cache, the block offset would be here. If this is smaller, then obviously the tag width will be extending instead of the size getting small. So this is also wrong. Smaller block size implies lower cache hit time. The hit time is solely depending upon the comparators used. So this option is also wrong. So the correct answer is option A. Smaller block size incurs lower cache miss penalty. This is a question from computer organization. Consider an instruction of the type load word R1, 20 of R2, which during execution reads a 32-bit word from memory and stores it in a 32-bit register R1. The effective address of the memory location is obtained by adding a constant 20 and contents of R2. Which of the following best reflects the address mode implemented by this instruction for operand in memory? Let's see option A, immediate addressing. In immediate addressing, we need to give a constant value in the instruction, which is supposed to be our operand. So this is not the case. We are not only giving a constant value, but we are having the contents of a register R2. So this is not the correct answer. In option B, register addressing, it would say that the operand is in the register. This is also not the case. We are adding a constant also here. Option C, it would say that the operand is in the address specified by the register. This is also not the case. This is also wrong. So the correct answer is option D, indexed addressing. Here we say that the operand is given by the index address. Now let's see how it happens. Load word R1, 20 of R2. So here this 20 is the base and contents of R2 content act as index. So R2 is basically the index register. So option D is the correct answer here. Such implementation of index addressing is suitable for iterative operations such as array implementation also. This is a question from algorithms. A sorting technique is called stable and 4 options are given. Let's see each options. Option A, if it takes order of n log n time. No, this is not the correct answer. B, it uses divide and conquer technique. No, this is also not the correct answer. C, relative order of occurrences of non-distinct element is maintained. Yes, this is what the stable property means. It means that the order in which the non-distinct elements are appearing in the array, they are maintained. So this is the correct answer. And some sorting techniques which are stable includes merge sort, insertion sort, etc. are stable, whereas quicksort, heap sort are examples of unstable sorting algorithms. This is a question from algorithms. Match the following and choose the correct answer in the order ABC. We are given heap construction, hash table construction with linear probing, AVL tree construction, and three time complexities are given: order of n log n, order of n square, and order of n. And we are asked to match the following. So let's see each options: A, B, and C. Let's try to match it. Heap construction. Heap construction would take order of n time to build the heap. So this is order of n and the option is R. So going by the options, now itself we can get the right answer. That is option D would be the correct answer because A is matching to R. Option D would be the correct answer. But let's see further regarding the other options. Option B, hash table construction with linear probing. And the option is Q, order of n square. Yes. In worst case for an element, we have to traverse the entire list to put the element in an empty slot. So it would take order of n for one element. So for n such elements, it would take order of n square. So the mapping would be heap would be constructed in this manner. B would be order of n square, and AVL tree construction would obviously be order of n log n. This is order of n log n. For a single node, it would take order of log n time to find its correct place and to fix its height. So for n such elements, it would take order of n log n. This is for the AVL tree construction. Option D is the correct answer here. This is a question from data structures. In a compact one-dimensional array representation for lower triangular matrix, that is all elements above diagonal are 0, of size n cross n, non-zero elements of each row are stored one after other starting from first row. The index of I, j in this new representation is. Here it is not mentioned that index starts from 0, 0 or 1, 1. So let's assume both. Another easier method to solve such question is, let's give options and see which can match. Let the array be 1, 0, 0, 2, 3, 0, 4, 5, 6. And the one-dimensional compact representation can be 1, 2, 3, 4, 5, 6. This would be the first row, this would be second row, and this would be the third row. And indexing, suppose assume the indexing starts at 0, 0. This will be 0, 0. And this would go on. Now let's assume index starts at 0, 0. Assume index is 0, 0. And this array index would be 0, 1, 2, 3, 4, and 5. Consider the element 5. The index here would be 0, 1, 2, 2, 1. So for 5, index is 2, 1. This is I, this is j. And it is stored in the index 4. This element is stored in the single dimensional array in the index 4. So going by the options, let's see what can be the index value. So I plus j, 2 plus 1, 3. 3 is not the index. J plus I minus 1 by 2, which implies 1 plus 2 minus 1 by 2, which is equal to 1 plus 1 by 2, which is equal to 1. This is also not the correct answer. Assume the third one, I plus j minus 1. 2 plus 1 minus 1, which is equal to 2. This is also not the correct answer. Last one, I plus j into j minus 1 by 2. This is equal to I is what? 2 plus 1 into 1 minus 1 by 2. This is also not the correct answer. Here we will get 2. So none of the options matches when we assume the index as 0, 0. Now let's assume the index as 1, 1. Index is 1, 1. And the array is again 1, 0, 0, 2, 3, 0, 4, 5, and 6. And compact representation is 1, 2, 3, 4, 5, 6. Assume index as 1, 1. So the index would be 1, 2, 3, 4, 5, 6. The index here would be 1, 1. Now again check for element 5. Element 5. For element 5, the index would be 1, 2, 3, 3, comma 2. Index is 3, comma 2, which is equal to I equal to 3, j equal to 2. Now let's calculate. Option 1, I plus j. 5 is equal to 3 plus 2 equal to 5. Yes, this can be a potential answer. A is true in this. Second one is j plus I into I minus 1 by 2. Here we have 2 plus 3 into 3 minus 1 divided by 2. We have 2 plus 3 into 2 by 2. Cut shorting this, we'll get answer as 5. So B can also be a potential answer. Let's assume C, I plus j minus 1, which is equal to 3 plus 2, 5 minus 1, 4. C is not the potential answer. Assume D, that is I plus j into j minus 1 the whole by 2. We have I is what? 3 plus 2 into 2 minus 1, 1, 1 by 2. We have 2 by 2, it is 1, 4. See, D is also not the potential answer. Among A and B, we have to choose the correct one. Now, consider the element 1. 1 is at index, assume we are writing it here. 1 is at index 1, comma 1. Let's see option A. 1 plus 1, 2. So option A is also not the answer. Option B is 1 plus 1 into 1 minus 1 by 2, which is equal to the index is 1. So 1 is the correct indent. So based on the options, option B is the correct answer here. This is a question from data structures. Which of the following permutation can be obtained in the same order using a stack, assuming the input sequence is 5, 6, 7, 8, 9 in that order? So let's consider each of the options. Option A, and let the stack be drawn as here: 7, 8, 9, 5, 6. So initially we are pushing 5, 6 and 7. Since we have to get the sequence of 7 first, we pop 7. So 7 is popped. Now to get 8, we push 8 into the stack and we pop 8 also. So 8 is also obtained. Now we push 9 and we pop it out of the stack. So we get 9 also. Now to get 5, it is not possible because right now only 5 and 6 is there in the stack, and to get 5 we have to pop 6, but then the sequence will not be in this specific order. So option A is not the right answer. So let's see the next option, that is 5, 9, 6, 7, 8. Let's draw the stack and see. We push 5, we pop it, so we get 5. Now to get 9 we have to push 6, 7, 8 and 9. To get 9 we pop it. Now to get 6, we cannot directly get 6 because we have to pop 8 and 7. So option B is also not the correct answer. Let's see the next option, 7, 8, 9, 6, 5. Let's draw the stack. To get 7, first of all let's push 5, 6 and 7. Now we pop 7, so we get 7. Now to get 8, we push and we pop 8. To get 9, we push 9, we pop 9. To get 6, now these three are not there in the stack. The topmost element is 6, so we get 6 after popping it. The next element is 5. After popping 5, we get 5. So option C is a correct answer. Let's see option D also. 9, 8, 5, 7, 6. Let's draw the stack. To get 9, let's push 5, 6, 7, 8 and 9. Now we pop it, so we get 9. Now we pop 8, so we get 8. Now we pop 5, now we pop 7, we get 7. Now to get 5, we have to pop 6 first. So this order is also not maintained. Option D is also not the right answer. So the correct option is option C. This is a question from algorithms. Quicksort is run on two inputs shown below to sort in ascending order. The orders are A equal to 1, 2, 3 till n, B is equal to n, n minus 1, n minus 2, etc. till 1. Let C1 and C2 be the number of comparisons made for A and B respectively. Then four options are given. So the worst case time complexity for quicksort is based on three conditions. One is array is sorted in ascending. 2. Array is sorted in descending. Third one is all elements are identical. In these three cases, the worst case situation for quicksort happens. So here A is the elements are arranged in increasing order. Here case B, the elements are arranged in decreasing order. So this conforms to the point 1 and 2. So in both cases, the number of comparisons made by A and B will be same. So C1 will be equal to C2. Option B is the correct answer. This is a question from data structures. A binary search tree is used to locate the number 43. Which one of the following probe sequence is not possible? So let's see each options. Option 1, we have root as 61. So 61 is greater than 43. So it should the next probe sequence should be to the left. We have 52, which is less than 61. 52 is greater than 43. So the next probe sequence should be to the left. We have 14. So it is also possible. Now 14 is less than 43. So the next probe sequence should be to the right. We have 17. So it is to the right. 17 is less than 43. So the next probe sequence should be to the right. We have 40. Now 40 is less than 43. So the next probe sequence should be to the right. We have 43. So A is correct. Okay. Next C option B. We have 10. We have to move to the right because 10 is less than 43. So next is 65. It is okay. Let's redraw it here. 10, 65. Next we have 31. 65 is greater than 43. So next sequence is here only 31. 31 is less than 43. So next sequence should be to the right. We have 48. 48 is greater than 43. So next sequence should be to the left. We have 37. That is also correct. 37 is less than 43. So next probe sequence should be to the right. We have 43. This is also okay. Next see option C. We have 81. 81 is greater than 43. So next sequence should be to the left. We have 61. 61 is greater than 43. We should move to the right. As we have 52, it is okay. 52 is greater than 43. We should move left. Since we have 14, it is also okay. 14 is less than 43. So we should move to the right. We have 41 here. So that is possible. 41 is less than 43. So we should move to the right. We have 43 here. So this is also okay. Let's next see the last one. We have 17. 17 is less than 43. So we should move to the right. We have 77. It is okay. 77 is less than 43. So we should move to the left. We have 27. Now 27 is less than 43. So we should move to the right. So we have 66. 66 is less than 66 is greater than 43. So we should move to the right. But we are moving to the left here. So this is not possible. This condition is violated. As a result, option D is the correct answer. This is a question from data structures. The characters of a string K, R, P, C, S, N, Y, T, J, M are inserted into a hash table of size 10 using the hash function h of x is equal to order of x minus order of a plus 1 mod 10. If linear probing is used to solve collisions, then the following insertion causes collision and we are given options. So since size is equal to 10, the ordering starts from 0 to 9. order is equal to 0 to 9. Let's draw the table. We have 0, 1, 2, 3, 4, 5, 6, 7, 8 and 9. So this would be the key and this would be the index. Let's calculate. So first we have k. K can be calculated as key is k. Order of k is the position of k in the alphabetic order, that is 11 minus order of a is 1 plus 10. Mode 10. We have 11 mode 10, which is equal to 1. Now we have r. R is in the location 18. So 18 minus 1 plus 1 mode 10. So we have 8. Essentially, this order of A plus 1 would cancel out. So whatever is the position of that number, mode 10 would be the answer. So P, its location is 16. So 16 mode 10 is 6. P, then we have C. C is at location 3. So 3 would be the index. Next one is S. S is at location 19. So 19 mode 10 is equal to 9. Now N. N is at location 14. 14 mode 10 is equal to 4. Till now no collision has occurred. Next is Y. Y is equal to 25. 25 mode 10 is equal to 5. Next one is T. T is at location 20. 20 mode 10 is 0. Next location is J. J is equal to 10. 10 mode 10 is equal to 0. So here collision has occurred. And the next one M. M is at location 13. So 13 mode 10 equal to 3. Here also collision has occurred. Now let's see the options given. Y, no collision has occurred. C, no collision has occurred. M, collision has occurred. And P, no collision has occurred. So based on the options, option C is the correct answer. M has caused a collision. This is a question from algorithms. Suppose the numbers 7, 5, 1, 8, 3, 6, 0, 9, 4, 2 are inserted in that order into an initially empty binary search tree. The binary search tree uses the reversal ordering of the natural numbers. That is 9 is assumed to be the smallest and 0 is assumed to be the largest. The in-order traversal of the resultant binary tree is. So the important property to note here is that in order traversal of binary search tree would result in ascending order, ascending sorted order output. Since 9 is the smallest and 0 is the largest, it would return in this format: 9, 8, 7, 6, 5, 4, 3, 2, 1, 0. Going by the options, option D is the correct answer here. Now we can do this in another method, that is to draw the binary search tree and then perform the in-order traversal. Let's try that method also. Here 7 is the root. 7 is the root. Next we have 5. As it's the reversal order, 7 is less than 5. So 5 will be here. Next is 1. 1 would be here. Next is 8. 8 would come here as it is less than 7 based on the question. Next we have 3. 3 means it's greater than 7, greater than 5, but less than 1. Next we have 6. 6 is greater than 7 but less than 5. So 6 would be here. Next we have 0. 0 would be here. Next we have 9. 9 is the smallest one. Next we have 4. 4 is greater than 7, greater than 5 but less than 1, but as well as less than 3. So 4 would be here. Next we have 2. 2 is greater than 7, 5 but less than 1 but greater than 3. So it will be here. Now let's perform the in-order traversal. To perform the in-order traversal, we traverse it like this. 9 would be printed, then 8 would be printed in this order 1, 2, then 7 would be printed. This would be 3, this would be 4, this would be 5, this would be 6, this would be 7, this would be 8, this would be 9, and this would be 10. So in this order it will be printed 1, 2, 3, 4, 5, 6, 7, 8, 9 and 10. So this order is 9, 8, 7, 6, 5, 4, 3, 2, 1 and 0. So option D is the correct answer here. This is a question from algorithms. A priority queue is implemented as a max heap. Initially it has 5 elements. The level order traversal of the heap is 10, 8, 5, 3, 2. Two new elements 1 and 7 are inserted into the heap in that order. The level order traversal of the heap after the insertion of the elements are. So let's draw the initial max heap based on the level order traversal given below. Initial max heap is equal to 10. Next level we have 8 and 5. Next level we have 3 and 2. Now we are inserting 1. 1 would be inserted here. So the max heap is maintained. Now next we are inserting 7. Since we are inserting 7, the max heap property is violated because 5 and 7 should be at the root. So these two are swapped and the final max heap would be 10, 8, 7, 3, 2, 1 and 5. Now the level order traversal would produce in this format 10, 8, 7, 3, 2, 1, 5. So the order is 10, 8, 7, 3, 2, 1, 5. Option D is the correct answer here. This is a question from data structures. The minimum number of stacks needed to implement a queue is, and 4 options are given, 3, 1, 2 and 4. So the minimum number of stacks required to implement a queue is 2. So the correct answer is option C. Let's see how it can be done in one method. Queue is denoted using Q and stacks are denoted using S1 and S2. There are many methods to implement queue using stack. One method is to make DQ operation costly. So to NQ, here we are making DQ costly. DQ costly. To NQ an element X into the queue, we simply push the element X into the stack S1. Now to DQ a particular queue. The first is both stacks empty, then return error. If stack 2 is empty, if S2 empty, then while S1 empty, we continuously pop or we push everything from stack 1 to stack 2. Push every element S1 to S2. Then in the last step, pop the top element from S2 and return it. This is one method where we can implement a queue using two stacks where DQ operation is costly. So the correct answer is option C, 2. This is a question from data structures. A strictly binary tree with 10 leaves and 4 options are given. Cannot have more than 19 nodes. Has exactly 19 nodes, exactly 17 nodes, and exactly 20 nodes. The basic concept is that a strict binary tree with n leaf nodes has 2n minus 1 nodes in total. Here n is equal to 10. So we can write 2 into 10 minus 1 is equal to 19 nodes in total. So the correct answer is option B, 19 nodes. This is a question from data structures. What is the maximum height of any AVL tree with 7 nodes? Assume the height of the tree with single node is 0. So given that height is equal to 0 when node is equal to 1. So the important property is maximum height will come when each level has minimum nodes. And the formula to calculate the minimum nodes in an AVL tree with height h is h of n, where it is equal to h of n minus 1 plus h of n minus 2 plus 1, and h of 0 is equal to 1 and h of 1 is equal to 2. Now let's calculate h of 2. That is with height 2, how many minimum will be the nodes? That is h of 1 plus h of 0 plus 1, which is equal to 2 plus 1 plus 1, which is equal to 4. Now h of 3, that is h of 2 plus h of 1 plus 1, which is equal to 4 plus 2 plus 1, which is equal to 7. So the number of nodes that are minimum and having maximum height with 7 nodes, the height is 3. So 3 is the correct answer and option B is the right answer here. So let's try to draw the tree here. One node, second node and third node, fourth and fifth, sixth and seventh. This is the maximum height of the tree with 7 nodes. So the height is 1, 2 and 3. This is the correct answer, option B. This is a question from data structures. Which one of the following property is correct for a red-black tree? And 4 options are given. Let's see option A. Every simple path from a node to a descendant leaf contains the same number of black nodes. Yes, this is true for a red-black tree. If a node is red, then one of its children is red and another is black. This is not true. If a node is red, then both its children are black actually. Both are black. This is wrong. Option C. If a node is red, then both its children are red. The correct answer here is both are black. This is also wrong. And option D, every node, every leaf node, that is sentinel node, is red. Here the property is that every leaf node is nil and it's colored black. So this is also false. So based on the options, option A is the right answer here. This is a question from data structures. The in-order and pre-order traversal of a binary tree are given. The post order traversal of this binary tree is. So let's first write the in order. We have D, B, E, A, F, C, G, and the pre-order is equal to A, B, D, E, C, F, G. So based on this, let's draw the binary tree first. Since pre-order is given, the first element is A, so A would be the root. So this, by seeing the in order, elements to the left of A will be left of A, and to the right it will be right of the tree. So pre-order first element is A. Now these elements would be to the left of A, and these elements would be to the right of A. Now let's see the next element B. This would be to the left. Next element is D. D is to the left of A as well as to the left of B. So D would be here. Next element is E. E is to the left of A and right of B. So E would be here. Next is C. C is to the right of A. So C would be here. Next would be F. F is to the right of A and to the left of C. So F would be here. And G is to the right of C. So it should be here. Now let's perform the post-order traversal. While performing post-order traversal, we will get it as D, then E, then B, then F, then G, then C, then A. Let's see the options. Option A will not be the answer. Option B also will not be the answer. Let's see option C. D, E, B, F, G, C, A. Yes, option C is the correct answer here. This is a question from operating system. A virtual memory system uses FIFO page replacement policy and allocates a fixed number of frames to the process. Consider the following statements. M. Increasing the number of page frames allocated to a process sometimes increase the page fault rate. And statement N. Some programs do not exhibit locality of reference. The point M is called Bellardi's anomaly. And this point is true. Even FIFO-based algorithms suffers from Bellardi's anomaly. And point N. Some programs do not exhibit locality of reference. This is also true because locality often occurs because code contains certain loops that tend to refer arrays or other data structures by indices. So we can write a program that does not contain loop, and as a result it does not exhibit locality of reference. So this option is also true. So both options M and N are true. Now let's see if N is the reason for M or N is not the reason for M. N is not the reason for M because the anomaly of Bellardi's anomaly is occurring for some specific pattern of page references and it is not confined to FIFO based replacement policy. So M and N are true and M and N is not reason for M. So the correct answer is option B. This is a question from operating system. Consider three CPU intensive processors which requires 10, 20 and 30 units and arrive at times 0, 2 and 6 respectively. How many context switches are needed if the shortest remaining time first is implemented? Context switch at 0 is included, but context switch at end is ignored. Let's draw the table first. So arrival time and burst time. Arrival times are 0, 2 and 6. Burst times are 10, 20 and 30. And processes are P1, P2 and P3. Now let's draw the Gantt chart for this. When the process P1 arrives at time 0, there is a context switch. It is denoted by delta. Delta means context switch at 0. Now at 0 only process P1 is there, so it's execute for 2 units. Now at unit 2 process P2 comes, but still P1 is having the shortest remaining time first, so P1 completely executes till 10 units. By this time process P2 and P3 would have come, and the shortest remaining time among these two is process P2, which has 20. So another context switch occurs. Now P2 executes completely till 30, then another context switch happens and P3 executes completely till 60. Then one more context switch happens to remove P3, but this context switch is ignored. So the total number of context switches are 1, 2 and 3. So the correct answer is option C, 3. This is a question from operating system. A process executes the following code. For I equal to 0, I less than n, I plus plus, and fork system call is called. The total number of child processes created are, and 4 options are given. First of all, let's understand what is a fork system call. A fork system call is used for creating new processes, which are often called child process. These child processes run concurrently with the process that makes the fork call, that is the parent process. So fork system call creates child process. Also, one important formula to remember is that for n fork calls, total number of processes are 2 to the power of n, and total number of child process is equal to 2 to the power n minus 1. So based on the options, option D is the correct answer. This is a question from operating system. Consider the following scheduling. A is gang scheduling, B is rate monotonic scheduling, C is fair scheduling. Match the table in the order of ABC. So let's see how we can match it. For A, gang scheduling. What is gang scheduling? It schedules related threads to run simultaneously on different processes. So it is related to threads. So A is related to T here. So going by the options, now itself we can say that A is the correct answer. But let's see what are the other options. B, rate monotonic scheduling. Here shorter duration jobs has higher priority. It is simple to implement but not flexible. Also not much overhead is there. So as a result, B is a real-time scheduling. That is rate monotonic scheduling is real-time scheduling. C, fair share scheduling. Here the CPU usage is equally distributed among system users or group and not to the processes. As a result, we are having a guaranteed scheduling. So C is S. So going by the options, option A is the correct answer. This is a question from operating system. A system uses FIFO policy for page replacement. It has 4 page frames with no pages loaded to begin with. The system first accesses 50 distinct pages in some order and then access the same 50 pages in reverse order. How many page faults will occur? So we have 4 page frames. These are the page frames. Assume 1, 2, 3 and 4. 1, 2, 3, 4. These are the 4 page frames. So access to the first 50 page frames will cause 50 page faults. So initially we have 50 page fault. This is because no page frames are loaded and access to each page frame is distinct. So in the first 50 we have 50 page fault. Now we are accessing it in the reverse order. Since we are accessing it in the reverse order, the last 4 pages which are referred are already there in the page frames. So those 4 pages does not cause page fault, and the rest 46 pages also causes page fault. So in the reverse order we have 46 page fault in reverse order when called. So total 50 plus 46 we have 96 page faults. So the correct answer is option A, 96. This is a question from operating system. Which of the following is false? Option A, user level threads are not scheduled by the kernel. This is true. User level threads are scheduled by the thread library and kernel knows nothing about it. So this is true. Context switching between user level threads is faster than context switching between kernel level threads. This is also true. Context switching between user level threads is much faster as they actually have no context switch as nothing is saved and restored, while for kernel level thread registers, program counter, stack pointer, etc. must be saved and restored. So this is also true. Option C. When a user thread is blocked, all other threads of the processes are blocked. This is also true. When a user level thread is blocked, all other thread of its processor are blocked. So this is also true. Now, kernel level threads cannot utilize multiprocessor system by splitting threads on different processor or cores. This is actually false. Kernel level threads can actually utilize multiprocessor system by splitting threads on different processors or core. So this is false. And based on the question, we are asked to identify which of the following is false. Option D would be the correct answer here. This is a question from programming languages. Which one of the following are essential features of object-oriented programming language? A. Abstraction and encapsulation. B. Strictly typed. C. Type-safe property coupled with subtype rule. Option D. Polymorphism in the presence of inheritance. Let's see the options. Actually, the object-oriented programming language has the important properties which includes abstraction, encapsulation, polymorphism, and inheritance. These are the four important properties of a object-oriented programming language, and going by the options, A and D are the correct answers. So option C, A and D only are the correct answers here. This is a question from data structures. Which languages necessarily need heap allocation in the runtime environment? Option A, those that support recursion. No, for recursion stack is enough. Those that use dynamic scoping. For this also stack is enough. Those that allow dynamic data structures. Yes, for this we need heap allocation. The dynamic data structures like linked list, tree, etc. requires heap for dynamic allocation and that use global variables. This is also stack is enough. So the question is which requires heap allocation? Option C, those that allow dynamic data structures is the correct answer. This is a question from programming. Consider the code segment and some integers are given and n is equal to 20. There is one outer loop I equal to 0, I less than n, I plus plus. There is one inner loop j equal to 0, j less than n, j plus plus. If I mod 2, then x equal to x plus 4j plus 5i, y equal to y plus 7 plus 4j, and finally m is equal to x plus y. We are asked to find out which of the following is false. The code contains loop invariant computation. This is actually true. This 5 into I can be moved from the inner loop towards the outer loop and can be placed here. This is a loop invariant computation. So this is true. Second one is there is scope for common sub expression elimination. 4 into j is happening twice. So 4j is a common sub expression. So we have there a scope for common sub expression elimination. There is scope for strength reduction. Yes, 4j can be written as 4 left shift j. So there is scope for strength reduction also. This is also true. There is scope for dead code elimination in the code. Actually, there is no scope for dead code elimination in this code. So this is false. And based on the question, the correct answer is option D. There is scope for dead code elimination, which is actually false. This is a question from operating system. Consider the following table, and a table is given. There is activation record, location counter, reference counts, and address relocation in one part. There is linking loader, garbage collection, subroutine call, and assembler in another half. Matching A, B, C, D in the same order gives, and 4 options are given. Let's see each options. A is activation record. Activation records are required to keep the information of subroutine calls. The languages which allow subroutine calls create an activation record whenever a subroutine call is made. So A can be mapped to R, that is subroutine call. Now itself we can eliminate A and B. Next, C and D are the viable candidates. So based on the options, B will be obviously mapping to S. Yes, for location counter is actually mapped to assembler. Assembler maintains a location counter to assign storage addresses to each instruction of the program. Now option C, reference counts. Reference counter tracks for each object. It counts the number of references made by it, and when the count reaches 0, the object becomes inaccessible and gets destroyed. So as a result, the reference count can be actually mapped to garbage collection. It is Q. So from here itself we can say that option C is the correct answer. But let's see option. What is address relocation referring to? Address relocation is usually performed by linking loader. So it is mapping to option P. D is mapped to P, and based on the options, option C is the correct answer. This is a question from operating system. A counting semaphore was initialized to 7. Then 20p or wait operations and x number of v or signal operations were completed. If the final value of the semaphore is 5, then the value of x will be what? In semaphores, p or wait operation means we are decrementing the value of the counting semaphore by 1. Decrement by 1. And v or signal means we are incrementing the value of the counting semaphore by 1. Increment by 1. Based on this concept, we can say that initially the counting semaphore is 7. S is equal to 7. Let S be the counting semaphore. After 20p operations, S will be equal to 20. Decrements are performed 7 minus 20, which will be equal to minus 13. Now this is 20p. Now x v operations, we have the final semaphore as 5. So minus 13 plus x is equal to 5. We can say that x is equal to 13 plus 5, which is equal to 18. So the number of signal operations that are performed is 18, and the correct answer is option C, 18. This is a question from digital logic design. We consider the addition of two 2's complement numbers bn-1, bn-2 till b0 and an-1, an-2 till a0. A binary adder for adding unsigned binary numbers is used to add two numbers. The sum is denoted by cn-1, cn-2 till z0 and the carry out by c out. Which of the following options correctly identifies the overflow condition? So the basic criteria for overflow are: when we add two positive numbers and we get a sign bit 1, then it is an overflow. When we add two negative numbers and we get a sign bit 0, then it is an overflow. Overflow is relevant only for signed numbers and carry is used for unsigned numbers. When the carry out bit and the carry in to the most significant bit differs, it is also an overflow. Now let's see each of the options. For option A, let n equal to 4. So the numbers be 0, 1, 1, 1 plus 0, 1, 1, 1. So this is 7, this is 7. So in reality 7 plus 7 equal to 14. But in 2's complement notation with 4 bits we cannot represent 14. So this is an overflow. We will get 1, 1, 1, 0. This overflows as in 2's complement we can store only up to plus 7. But the overflow condition in A returns false as Cout is 0. So this option A is not correct. Let's see option C. Let's add the numbers 1001 plus 0001, which is equal to 1010, where there is actually no overflow as we are adding -7 plus 1. We get -6. But the given condition, it says that as Cout equal to 0 and Cn minus 1 equal to 1, it says it is an overflow. So even though when there is no overflow, as it says it is an overflow, this is also wrong. Let's see the option D. This is also not the correct option. Consider the following example: 1111 plus 1111. We get 1110. This is actually -1 plus -1, which is equal to -2, where there is actually no overflow, but the given condition says that there is overflow. So this is also not correct. So based on the options, option B is the correct answer. Actually, in the question given in ISRO paper, it is actually wrong because all the options are wrong. The option B in the actual paper is AN-1 bar, BN-1, CN-1 bar plus AN-1, BN-1 the whole bar into CN-1. This was the option that was actually given in the ISRO question paper, and this option is actually wrong. So this option is modified a bit to get the correct answer. And based on the options, option B would be the correct answer here. This is a question from C programming. We are given a function fun which accepts an integer x, and if x is greater than 100, we call fun equal to x minus 10, else fun is equal to fun of x plus 11. So f of 95. We are calling for the input x equal to 95. What will be the return value? F of 95. What happens is, since 95 is less than 100, f of 106 is called. Since 95 plus 11 is 106. Now for 106, what will be the return value? We will get f of 106 is greater than 100, so 106 minus 10 is 96. Now f of 96 is called. When 96 is called, since x is less than 100, we get f of 96 plus 11, we have 107. Now upon calling f of 107, it returns, since x is greater than 100, x minus 10, we get f 97 as the result. So f of 97 is now being called. Upon calling f of 97, since 97 is less than 100, we get f of 97 plus 11, we get 108. Now f of 108 is called. F of 108. F of 108, it returns 98. Then we call f of 98. Upon calling f of 98, what happens? Let's write it here. F of 98 we'll get, since 98 is less than 100, we call f of 109. Now f of 109 is called. It would return, since 109 is greater than 100, we get f of 109, the value would be 99. So f of 99 is called. Now since f of 99 is getting called, we see 99 is less than 100. What happens is f of 99 plus 11, we get 110. Now f of 110 gets called. Upon calling 110, we get f of 110 would return 100. So f of 100 gets called. Since x is equal to 100 only, it's not greater, we can again call f of 111. Now f of 111 gets called. F of 111 would return f of 111 minus 10. We will get 101. We again call f of 101. Upon calling 101, what happens is 101 is greater than 100. We get 101 minus 10, which is equal to 91. So this would return a value of 91. Let's see if it is present in the options. Yes, option C 91 is the correct answer here. This is a question from C programming. We are given a function which accepts an integer variable. There is a count variable also. There is a while loop which runs till the number is greater than 0. The count is incremented and we are right shifting the number by 1. And the input that we are given is 435. 435 in binary can be represented as 110 1100 11. Initially count is equal to 0 also. Now while num, this is num is valid, count is incremented, so count now becomes 1 and we are right shifting this number by 1 bit, so this bit is not considered now. So we have 0, we are appending 0 to the left, 1 1 0 1 1 0 0 1. Now again this loop is encountered, so count becomes 2 and we are again right shifting this by 1 bit, so we will get 0 0 1 1 0 1 1 0 0. Again this is valid, so count becomes 3 and this bit is right shifted. Now we have 0 0 0 1 1 0 1 1 0. Let's denote count as C for the time being. Now this number is also valid, so C becomes 4 and we are right shifting this. So we have 0 0 0 0 1 1 0 1 1. Now again while running into the while loop, this number is valid, so C becomes 5 and this bit is right shifted. So we have 0 0 0 0 0 1 1 0 1. Again inside the while loop, C becomes 6 and this bit is right shifted. We will get 0 0 0 0 0. We have 1 2 3 4 5 zeros here, 1 2 3 4 and 5 1 1 0. Again this number is valid, we are incrementing the value of counter to 7. We are right shifting it by 1 bit. We have 1 2 3 4 5 6, total 7 zeros in the beginning, 1 2 3 4 5 6 7 1 1. Now again this number is valid, so count is incremented to 8 and we are right shifting it. We have 1 2 3 4 5 6 7 8 and 1. Again the counter is incremented to 9 and we are again right shifting, so it becomes 0 0 0 0 0 0 0 0 0. Now this loop is not satisfying the condition because we will get while of 0. So this loop is not satisfied and we are returning the value of count. Count is actually 9 here. So the correct answer is option A 9. This actually counts the number of bits in the binary representation of a number. So we have 1, 2, 3, 4, 5, 6, 7, 8, 9. 9 bits in the binary representation of 435. So this function is actually calculating that and the correct answer is option A 9. This is a question from Digital Logic. Which of the following set of components is sufficient to implement any arbitrary Boolean function? A. XOR gate and NOT gate. B. 2 to 1 multiplexer. C. AND gate, XOR gate and 1. D. 3 input gates that output A, B plus C for the inputs A, B and C. Let's see each options. Option A is XOR plus NOT gate. XOR and NOT gates can only make XOR and XNOR. So it is not functionally complete. We can make A XOR A bar equal to 1 and A XOR A equal to 0 using this. So this is not functionally complete. A cannot be the answer. 2 by 1 multiplexer. Yes, using 2 by 1 multiplexer, we can functionally complete provided we have external 1 and 0 available. So this is a correct option. How to make it? For NOT gate, we can use X as the select line and use 0 and 1 as the inputs. For AND gate, use Y and 0 as input and X as select. With AND and NOT, any other gate can be made. So 2:1 multiplexer is an option. Option C, AND gate, XOR and 1. XOR can be made to use in such a way that NOT gate can also be made using XOR, that is A XOR 1 is equal to A bar. So we have AND and NOT functionality here. Again, this requires an external input of 1 but still we can make it functionally complete. So option C is also correct. Next we have three input gates that output A, B plus C for the inputs A, B and C. We have A, B plus C. Using C equal to 0 we get an AND gate. Using B equal to 1 we can get an OR gate. But we cannot derive NOT gate from here. So option D is also not correct. So B and C is the correct answer and option B would be the correct answer here. This is a question from software engineering. Consider the following. We are given a table. On the left column, we have conditional coverage, equivalence class partitioning, volume testing, and beta testing. On the right column, we have black box testing, system testing, white box testing, and performance testing. Matching A, B, C, D in the same order gives, and four options are given. So let's see each option. Condition coverage. Condition coverage tests each one of the Boolean expression with values true and false. For this, the tester has to know the code. Hence, it is white box testing. So A is mapped to R. Let's see how the options can go. From this itself, we can see that B, C, and D are directly eliminated. A is the correct answer. We can stop it here, but let's see how the other options are happening. Equivalence class partitioning. It divides the input test data into each partition at least once of equivalent data from which test cases can be derived. Only input values are needed, not the code. Hence, it is a black box testing. B is mapping to P. This is correct. Now S or option C, that is volume testing. In volume testing, it checks the system performance with increasing the volume of data in the database. This is actually a type of performance testing. So C is mapping to S. This is also correct. Beta testing. Beta testing is a kind of system testing that is done at the customer site to validate the usability and the functionality. So it is a system testing. So D is mapping to Q. So based on the options, A is the correct answer here. This is a question from machine learning. Consider the results of a medical experiment that aims to predict whether someone is going to develop myopia based on some physical measurements and hereditary. In this case, the input dataset consists of the person's medical characteristics and target variable is binary. That is 1 for those who are likely to develop myopia and 0 for those who aren't. This can be best classified as. From the question, we can say that this is a classification task. Essentially, binary classification. 0 class is for develop, those who don't develop myopia. Don't develop myopia and 1 can develop myopia. So let's see the options. First is regression. Regression is generally used to predict continuous values such as 2, 3, 4 or 5. So this is not suiting with the requirement given in the question. So regression cannot be the correct answer. Option B is decision tree. Yes, decision tree can be used for the task of classification and it comes under supervised learning. Based on the question, we are performing supervised learning and a classification task. So decision tree can be a right answer. Let's see the next option, clustering. Clustering is usually used in unsupervised learning, so it is preferred for input data which are not more related and form them into groups. Here we have supervised data or we have data initially with us. So clustering cannot be the appropriate choice. And association rules are those such that we are using if then reasoning method to support the confidence technique to give a particular result. So this is also not correct. So based on the question and the options, option B, decision tree, would be the best method to choose here. This is a question from data warehousing. Which of the following related to snowflake schema is true? Let's see each option. Option A, each dimension is represented by a single dimensional table. In Snowflake schema, it is an arrangement of tables in a multi-dimensional database. So this is false because we are using multi-dimensional and not a single dimensional database. So this is false. Second one is maintenance efforts are less. This is also false because Snowflake schema requires high maintenance effort to avoid data update and insert anomalies. This is also false because high maintenance is required. And dimensional tables are normalized. Yes, this is true. This is an important feature of Snowflake schema. So this is true. Normalization of dimension tables are done in order to remove data redundancy and thereby reducing the space required to hold the data. This is done to reduce data redundancy. And option D, it is not an extension of star schema. Actually, Snowflake schema uses normalization of dimensional tables in star schema. So this is also false. So based on the question, we are asked to find out which of the following is true. So option C, dimensional tables are normalized, is the correct answer here. This is a question from operating system. Which of the following is not true with respect to deadlock prevention and deadlock avoidance scheme? Let's see the options. Option A. In deadlock prevention, the request for resource is always granted if resulting state is safe. This is actually not true because deadlock prevention tries to avoid one of the four conditions for deadlock, that is mutual exclusion, hold and wait, circular wait, no preemption of resources. So in deadlock prevention, it tries to break one of these four conditions for deadlock. It may reject resource request even if the resulting state is safe in order to break the necessary condition. So this is not true. That is option A is not true. In deadlock avoidance, the request for resources is always granted if the resulting state is safe. Yes, this is true. Deadlock avoidance requires knowledge of resource requirements a priori. Yes, we need to know how is the resource requested in advance to perform deadlock avoidance. Deadlock prevention is more restrictive than deadlock avoidance. This is also true because here we are trying to avoid or break these four conditions. So this is much more restrictive than deadlock avoidance. And option A is false. So the correct answer here is option A. That is deadlock prevention. The request for resource is always granted if resulting state is safe. This is false and we are asked to find out which of the statement is false. Option A is the correct answer. This is a question from operating system. Consider the disk sequence with 100 cylinders. The request to access the cylinder occur in the following sequence and we are given a sequence. Assume that the head is currently at cylinder 50. What is the time taken to satisfy all the requests if it takes 2 milliseconds to move from one cylinder to adjacent one and shortest seek time first policy is used? The policy used is shortest seek time first. Let's write the request in ascending order. We have 4, we have 2, we have initially 2, 4, 6, 7, 10, 15, 19, 20, 34 and 73. These are the requests. Currently the head is at this position. Now based on shortest seek time first, it will try to move to either 34 or 73. Since the difference between 34 to 50 is 16 and 50 to 73 is 23, it moves to this direction. Then since the next shortest seek time it has to travel is only 14 if it goes to 20, if it has to go to 73, from 34 to 73 it has to go. So what happens here is that from 50 it directly traversal till 2 to satisfy all the requests. Then from 2 it moves to 73. This is how it goes. This is the first direction, this is the second direction. So how many seek happens? So to complete one we have 50 minus 2, that is 48 moves, and to complete 2 it requires 73 minus 2, that is equal to 71 moves. So total 48 plus 71, we have 119 moves. So in total, it takes 2 milliseconds for each seek. So 119 into 2, we have 238 milliseconds as the answer. So the correct option is option B, 238. This is a question from C programming. Consider the following C function. We are given a function, we are given a character array C, and it is accepting ICRB CS IT 17. There is a character pointer P. Then we are asked to print and see what is the output. So one basic important concept to remember is that percentage %s is expecting an address and it tries to print from that address till null is encountered. This is null. So from the options, we can say that since null would be at the end of 7, we can say that whichever output has value 7 at the end, that would be the correct answer. Here SI is there, IT, TI and 17. So from here itself, we can say that option D is the correct answer. But let's see how to solve this. This is the shortcut method and this method is the long method. This is the array. I, C, R, B, C, S, I, T, 1, 7 and null. The indexes are 0, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. Suppose the starting address is at 100. We have 101, 102, 103, 104, 105, 106, 107, 108, 109 and 110. Now this P is a pointer which is storing the value of 100 and it is pointing here. And we are asked to print the value of C plus P of 2 minus P of 6 minus 1. C means it is pointing to this 100 plus P of 2. P of 2 means it is pointing to R. R here. The ASCII value of R is 82. So plus 82 minus P of 6. P of 6 means it is pointing to I. That is the ASCII value of I is 73 minus 73 minus 1. This is what the starting address would be looking like. The result of this would be 108. So it will be pointing here. Now percentages will print 1, 7 and null. So the correct answer would be, since null is not printed, it will print till null. So 1, 7 would be printed and option D is the correct answer. This is a question from linear algebra. If C is a skew-symmetric matrix of order n and X is n cross 1 column matrix, then X transpose Cx is. First of all, a skew matrix is a matrix such that if matrix is A, then a matrix A is said to be skew symmetric if A transpose is equal to minus A. Now let's consider C to be a skew symmetric matrix and let it be 0 B C minus B 0 D minus C minus D and 0. Now let X be n cross 1 column matrix of order P, Q and R. Let's calculate Cx. Cx will be BQ plus CR. First row, first column. We are multiplying BQ plus BQ plus CR. Now we have second row is minus BP plus DR. Third row is minus CP minus DQ. This is Cx. Now X transpose CX is PQR would be X transpose into BQ plus CR minus BP plus DR minus CP plus minus DQ. What would be the result? We will get PBQ plus PCR minus PBQ plus QDR minus PCR minus QDR, which in return we can rewrite it as cutting all those plus and minus, plus and minus, plus and minus. So it will find result in 0. So the correct answer is it would be a null matrix actually. So option B, null matrix, is the correct answer. This is a question from digital logic. A 32-bit adder is found by cascading 4-bit carry look ahead adder. The gate delays for getting the sum bits are. So here each carry look ahead adder will have bits A31, A30, etc., A0 and B31, B30, etc., B0 readily available to it. So in the first cycle, each will compute the XOR operation on its 4 bits. Now after that, each carry look ahead adder will take 2 cycles to pass on the carry out information to the next carry look ahead adder, and then at the end one more cycle is needed to get the sum output from the 8th carry look ahead adder. Hence the total gate delays would be 1, which would be the XOR cycle, and then 2 cycles for passing the carry out to the next CLA. So we have 8 carry look ahead adders, so 2 into 8, then ultimately one more delay, that is one more cycle needed to get the sum from the 8th carry look ahead adder, so 1. So the total answer is 18, and based on the options, option B is the correct answer. This is a question from digital logic design. In IEEE floating point representation, the hexadecimal number 0x00000000 corresponds to, and 4 numbers are given. So let's write this number, which is a hexadecimal number, in 32-bit form, since IEEE floating point representation is a 32-bit form. 0x C00000000, which is equal to, C can be written as 1100. Next everything is 0, 0000, 0000, 0000, 0000. So now we have written completely this. Then next is 0000, 0000, 0000. This is the 32-bit representation. In IEEE floating point representation, first bit is the sign bit for the mantissa. Next 8 bits represents the exponent, and rest, or the last 23-bit, represents mantissa value. The exponent is biased and the value can be 2 to the power of exponent bits minus 1 minus 1, which is equal to, the number of exponent bits are 8, 2 to the power of 8 minus 1 minus 1, which is equal to 127. So finally we can write the number as number is equal to minus of 1 to the power of s into 1 point m, where m represents the mantissa, into 2 to the power 128 minus 127, which is equal to minus 1 into 1 point m is the mantissa. Since mantissa here is all the values are 0, we get 1.0 into 2, which is equal to minus 2.0. This is the correct answer. And based on the options, option D is the right one. This is a question from database. Consider the following table faculty with faculty name, department, office, rank, and date hired as the attributes. And the table is given. Assume that no faculty member within a single department has same name. Each faculty member has only one office identified in office. 3NF refers to third normal form and BCNF refers to Boy's code normal form. Then faculty is in and 4 options are given. So from this, the trivial dependencies that are identified is trivial dependencies, that is equal to faculty name implies department, comma, rank, comma, office, comma, date hired. And the second one is office determines the department. So given each faculty member has only one office identified, it means that faculty name can be considered as a primary key. So here faculty name is the primary key. That's an important point. Therefore, faculty name, the functional dependency faculty name is in 3NF as well as in BCNF because faculty name is the primary key. So consider the second functional dependency. Here, the functional dependency office is not in BCNF because office is not a super key, but department is in 3NF as it is a prime attribute because of the property department, comma, rank forms a super key. So the attribute faculty name is in BCNF, but office is not in BCNF. So the correct option is faculty is in 3NF but not in BCNF. So the correct option is option B. This is a question from databases. Consider the following query. Select E dot number, comma, count star from employees E, group by E dot number. If an index on employee number is available, the query can be answered by scanning only the index if, and 4 options are given. So first option is the index is only hash and clustered. Second is the index is only B plus tree and clustered. Third one is index can be hash or B plus tree and clustered or non-clustered. Fourth one is index can be hash or B plus tree and be clustered. The correct answer is option C. Index can be hash or B plus tree and clustered or not clustered. In clustered indexing, it means that cluster indexing is equal to indexing on non-key field, comma, ordered file. This is the concept of cluster indexing. Every other index are non-clustered. Since no information about the search key, that is employee number, is given, that is whether it is sorted or not, and we do not have any information about the data file, that is it should be sorted or not. And so non-clustered index as well as clustered index are possible here. So as a result, option C, it can be clustered or non-clustered and can be hash or B plus tree. Correct answer is option C. This is a question from databases. We are given a schema having the tables sailors, boats, and reserves. Two boats can have the same name, but the color differentiates them. The two relations are performed this following operation. If slash is the division operation, the above set of relations represent the query. Slash means division operation. This is the important point. Division is typically required when you want to find out entities that are interacting with all entities of a set of different type of entities. So all entities, that is the important point here. So based on the query, according to division operation, temp SIDs, this is temp SIDs. Temp SIDs would be the result of this division operation. Temp SIDs gives out SID and BID of all who have reserved all boats called Ganga, and projection of S name will return sailor names who have reserved all boats called Ganga. Let's see which are the following options. Option A, name of sailors who have reserved all boats called Ganga. Yes, based on the options, option A is the correct answer here.